Hello. Today I'm going to speak about irrational functions. Irrational functions can also be known as radical functions. Are functions in which I can find a root. So the general form of an irrational function is fx equal coefficient multiplied by square root of coefficient, variable, coefficient, all below the root, plus another coefficient. Depending on the values of a, b, c, and d, I can find different graphs, but always with the same shape. The same shape is a half of sideway parable. A parable, as you already know, is something like that. A sideway parable is, for example, something like that. So half a sideway parable would be, for example, this part. What should I do to represent this sort of functions? Okay, I take the function again. First of all, as I do with many of the other functions, I have to calculate the domain. As I have a square root, I know to study the domain, I have to take the inner part of the root and calculate for which values of x it's higher or equal than 0. For example, if I have square root of 3x plus 6, I'll have to calculate 3x plus 6 higher or equal than 0. The 6 I send to the other side, 3x higher or equal than 6. And now dividing by 3 both sides, x is higher than 2. In this case, the domain will be numbers bigger or equal than 2. It can be written as from 2 to plus infinity. But if I have for example this root, I'll have to calculate when this is higher or equal than 0. In this case, as the x is negative, I send to the other side, and I have 5 higher or equal than x, so x is lower or equal than 5. And the domain will equal from minus infinity to 5. Okay, so once I have the domain, I know that these are my axes. This will be a certain value, and I know I have function in this side of this line, and here nothing. Or, sorry, I'll have here function and here nothing. Okay, so the domain allows us knowing which part of the plane will contain the function, the graph of the function. Next step will be calculate the vertex. As I have a variable, in fact, variables always have a vertex. Remember, we have the function which is a multiplied by bx plus c plus d. To calculate the vertex, I don't have to use the formulas I have for quadratic functions. The vertex is always placed, the coordinate x is the coordinate that makes the inner part of the root equal to 0. And I solve, so x will be minus c divided by b. And when I substitute this number in the function, I'll have the root will value 0 multiplied by a continues being 0, and the d gives us the point of the vertex. So imagine, for example, that we know our variable is placed this side. As this value is minus c divided by b. Now I can place here the vertex. Okay, and the vertex is the origin of the function in some way. For example, if my function is 3 square root of 2x plus 4 minus 5, for example, the vertex will be placed, I take 2x plus 4 equal to 0. So 2x will be minus 4 and x will be minus 2. So here the x coordinate will be minus 2. And now when I substitute, the root value 0, so I have minus 5. Then minus 1, minus 2, minus 1, minus 2, minus 3, minus 4, minus 5. Here is the vertex of our variable. Okay? And the last step, always continuing with the same function, is looking at the value of a. If a is higher than 0, I have the upper half of variable. So I mean from the vertex to this side or from the vertex to this side, according with the result I have in the domain. And if a is lower than 0, I have the lower half of variable. So from the vertex to the right or from the vertex to the left. Okay, let's see an example. The function equals minus 3 square root of minus x plus 2 minus 1. First of all, domain. To calculate the domain, I take the inner part of the root and I calculate when that expression is higher or equal than 0. So 2 must be higher or equal than x and x lower or equal than 2. it means that the domain is from minus infinity to 2. So I can draw my axis I place the 2, and here I can take another color. And here I have no function. Okay, I only have function in the other part of the plane. Now I have to calculate the vertex. The vertex will be placed as 2 minus 1. So I place this number here, this point, sorry. And finally, as minus 3 is lower than 0, I have the lower half of variable. So as I have to continue to my left, the graph of the function will be something like that. Okay, and that's all. If I want to calculate some values to represent it in a better way, I can construct a values table. Values table should contain at least 5 points. But I choose them. So I don't mind if you consider if you give the value 3, it's too difficult to calculate the square root because it's not exact. You choose these values. So it means if you find any difficult value, don't give this value. Okay? The first value I have to give is always the vertex. Sorry. Now, I have to give lower values. For example, I can give value 1. Why? Because minus 1 plus 2 is 1. This root I know how to calculate. Square root of 1 is 1 multiplied by minus 3 is minus 3, minus 1, minus 4. What happens if now I give the value 0? 0 will conduce me to have the square root of 2. And it's not an exact value. So I don't give this value. The next value I can give is minus 2. Because minus 2 plus 2 is 4. And I know how to calculate the square root of 4. 4 multiplied by minus 3 equals minus 6, minus 1, minus 7. Next value, I should give value minus 7. How do I find this value? This makes me have square root of 0, square root of 1, square root of 2, of 4, sorry, square root of 9, square root of 16, perfect square, okay? This is the easiest way to calculate everything. And finally, for example, to have square root of 16, I have to give value minus 14. Minus 12, minus 13. But as I always tell you, it's not necessary the values table to represent in approximate way the function, what is what I'm going to ask you. And that's all.